On number 3, we're trying to solve the inequality. And my first step is to get everything onto one side and 0 on the other. So I want to move that 4x and that 16 over. So x cubed plus 4x squared minus 4x minus 16 is greater than or equal to 0. Now on question number 1, it was already factored for us. So here we actually have to factor it ourselves. So because it's 4 terms, I'm going to use factor by grouping. So if I just look at the first 2 terms, I want to take out a GCF, and that would be x squared, leaving me with x plus 4. And then I want to take a GCF out of the second 2 terms, which would be a negative 4. And that would leave you with x plus 4. So then if you complete the factor by grouping, you want to take out the x plus 4, and then this is x squared minus 4. Okay, you always want to factor as far as possible. The x plus 4 is okay, but the x squared minus 4, this can actually be factored further. This is a difference of 2 squares. So this turns into an x plus 2 and an x minus 2. And the x plus 4 I'm going to carry down, and this is now completely factored. So if I were to set each of these equal to 0, I would get x is equal to negative 4, x is equal to negative 2, and x is equal to positive 2. So these represent the cutoff points of my number line. So this is negative 4, negative 2, and 2. And I want to pick test points using the table command. So if you've gone through number 1, you've already set your table up in the correct mode. So if you plug in, well, first of all, you need to plug the actual equation into your y1. But then once you do that, if you go to the table, so second table, and then start entering in your cutoff points, negative 4, negative 2, and 2, you should see that they all equal 0 here. So that is a good check to make sure that you factored correctly and that you have the right cutoff points, because they should always be equal to 0. Then I picked some numbers that are in between those cutoff points, so numbers that are going to represent the sign of the region. So negative 5, if you plug that in, you get a negative 21. And the only thing I really care about that is the fact that it's a negative, not the fact that it's 21. So this would be negative. Then if we plug in negative 3, we get 5, a positive 5. So that's going to go here. Again, I'm plugging in numbers that just lie in between these numbers. If you plug in 0, you get a negative 16. And then if you plug in 3, you get a positive 35. So positive number here. Again, you don't need to pick specifically negative 5, negative 3, 0, and 3. I just pick those numbers, again, because they lie with or in between these cutoff points. But I mean, you could pick, for this region over here, you could have picked negative 10, you could have picked negative 100, as long as it's something less than negative 4. I just picked negative 5. Okay, so now I need to decide which regions do I actually want to keep as part of my final answer. So if you look at the greater than or equal to 0, that's what tells us. So this says it's greater than or equal to 0. So we want the positive regions and where it's equal to 0. So I do want these regions, and I am going to include the cutoff points, so I do want to use brackets here because it's greater than or equal to 0. So that'll be bracket -4 to -2, and then bracket 2 to infinity. So any number within this region or these regions would make my original question true. So it's an interval of answers that is our answer.